Hi guys, welcome to Algebra 1, Lesson 21. Today we're going to be talking about equations, equivalent equations, solving equations, the additive property of equality, and all of that fun stuff. Let's jump right in. So, if you look at these two equations, x plus 6 equals 9, and x plus 10 equals 13. These are two different equations, they have different numbers. But if they have the same solution, the same root, the same number that satisfies them, then they are equivalent equations. Equivalent equations are two or more equations that all of their roots, all of the numbers that will satisfy them, that will solve them, are the same. So let's look at these two equations. If we say that x equals 3, we know that 3 plus 6 is 9, and 3 plus 10 is 13. So that works for both equations. So these are equivalent equations because they have the same solution, 3. And 3 is the only number that will satisfy this equation and that will satisfy this equation. So they are equivalent equations. They have the same solution. The same variable will fit into both of them. Now I want you to look at this true statement right here. 2 equals 2. That's true, right? We know that 2 is 2. It doesn't somehow change when it got to the other side of the equal sign. Well, let's say now I add 4 to both sides of my 2. 2 plus 4 equals 2 plus 4. Then I get the true statement, 6 equals 6, because 2 plus 4 is 6, 2 plus 4 is 6. So I didn't change anything when I added a number to both sides. I kept it the same. What about if, now for this, I added 2 to the 4 behind the 2. But what if instead I put the 4 in front of the 2? Am I going to get the same answer? Yeah, I am. 4 plus 2 still equals 6. So 4 plus 2 equals 6. So it doesn't matter which order I add, which number I add first. And we've already looked at this, that it doesn't matter the order that you add numbers or that you multiply numbers. But right now we're talking about adding. So it doesn't matter what order. So we call this the additive property of equality. That means if I say that a plus c equals b plus c, that means I can switch it. I can say that, putting c in front, c plus a equals c plus b. I use this kind of property to be able to solve equations. It's this property that helps us to extrapolate, to develop our system of solving equations, which you have solved before. So let's look up here at x plus 4 equals 6, this equation in pink. Now you see it repeated over here. We're going to get to that in just a minute. So x plus 4 equals 6. I want to find out what x is. I want to know what number will satisfy my equation. What is the root of this equation? So to do that, I know that I need to do the opposite of whatever is being done to x right now in order to solve for x. So the opposite, I'm adding a positive 4. So the opposite would be to, now you're probably saying subtract 4, Miss Ashley, and you're right, it is. But what is subtraction the same as? It's the same as adding a negative. So I want you to kind of get that into your heads so that when we put in negative numbers, it doesn't confuse you. So we're going to add a negative 4 to both sides. I'm going to give myself a little more room with this. So give me just a second to reset this. So there's a little more space. Okay. So I'm adding a negative 4, which I can write the same way as subtracting 4. You can put an equal sign here in between your 4's, or you can leave the equal sign out. It doesn't matter what you choose to do. It's the same answer. So here I have x plus 4 minus 4, or adding a negative 4. That cancels out the 4 because it becomes x plus 0. So I don't need to put the plus 0. I just have x left. Oops, let me move that over. Okay, so I just have x left, which equals 6 plus a negative 4 is 2. So I say that x equals 2. Now I need to check that, okay? Now the additive property of equality comes in that I'm adding the same thing to both sides. Whatever I do to one side, I have to do to the other. So now let's check it by putting 2 in place of x. 2 plus 4 equals 6. I'm running out of room. I know that 6 equals 6. So my equation checks out. Now I know it's really hard for you to see that. You probably can't see it. But you know what I wrote as you've written it before. Okay, on your math problems, this is something you need to do, the checking part, okay? Let me write it down here bigger just to remind you what it looks like. 2 plus 4 equals 6. I put the 2 back in place of x. 2 plus 4 is 6 equals 6. It checks, okay? That's what your check needs to look like. Yes, you need to check all of your equations, okay? You don't have to do your problems over twice. You don't even have to check every problem. But this one you do need to do. When you solve equations, you have to put it back in place of your variable to make sure that it checks out. If you're not doing that, well, you know what's going to happen. Okay. So let's look over here. I promised that we would go over here for a second. This is just to show you that there's more than one way of writing it. So this is how I wrote the problem out right here. I wrote it out underneath and kind of subtracted it in a column. You can do that, or you can do this, where you write it out to the side. So here I have x plus 4 plus a negative 4, or you can write minus 4, either way. And then 6 plus a negative 4. So here I've written it all out in a line. It's the same thing that I have over here, just a different format. So 4 plus negative 4 cancels it out. All you're left with is x equals 6 plus negative 4 is 2. Put 2 in place of x. 2 plus 4 equals 6. 2 plus 4 is 6. So 6 equals 6. And my equation checks. Okay? All right, let's try some practice problems before you go to your practice. Here I have x minus 3 equals 12. So I need to do the opposite of whatever I'm doing with x right now. Since I'm adding a negative 3, I'm subtracting 3, what does that mean I need to do? Add a positive 3. I'm going to keep doing it in the column way. So I have plus 3 on this side, plus 3 on this side. That cancels out my 3 here, so I'm just left with x. X equals 12 plus 3 is 15. Now I'm going to check it. I'm going to put 15 in place of x minus 3 equals 12. 15 minus 3 is 12, so 12 equals 12. My problem checks. Let's try this next one. X plus 1/4 equals negative 3/8. Ooh, fractions in our equations. Your favorite. Okay, so I'm adding a 1/4. What's the opposite of that? Adding a negative 1/4, or subtracting 1/4. So whatever I do to one side, I have to do to the other. This is going to cancel out my fraction over here, so I'm left with x equals. Now here's the fun part. I cannot add these fractions until they have the same denominator. So I have to find their common denominator, which I know is 8. So this fraction stays the same, negative 3/8. 4 goes into 8 2 times. 2 times 1 is 2. So I have 2 8s here. So I have negative 3/8 plus a negative 2/8, which is 5 8s, negative 5 8s, excuse me. So I have negative 5 8s as my answer. See the negative? Okay, right there, negative 5 8s. So now I'm going to put negative 5 8s in place of x. Negative 5 8s plus 1/4 equals negative 3 8s. I change my 1/4 to 2 8s so that I can add it. So I have 5 minus 2 is 3. Denominators stay the same. My negative number has the greater absolute value, so it's a negative. Negative 3/8 equals negative 3/8. My answers match, so my problem checks. Not so hard, right? You got this. Okay, we have one more example before your practice. I'm going to go ahead and erase this so we have room to do it. All right, this one is k plus by doing the opposite of whatever I'm doing to k. I'm adding 2 1/3, so I need to subtract 2 1/3. Or add a negative 2 1/3. On this side, it's super easy. I'm just left with k. On this side, I need to change a few things, right? I'm adding a negative 2 1/3. Well, I need to change my fraction so that it is matching the denominator of my other fraction. What's the common denominator for 9 and 3? 9, right? So this number, let me erase a little more so we have more room. Here we go. So this is going to stay 2 ninths. This becomes negative. Our whole number stays the same, 2. Change our denominator to 9. 3 times 3 is 9, so I have 1 times 3 is 3. So it's negative 2 and 3 ninths. Now you might be asking, Miss Ashley, I've forgotten, how do I do this? Okay, so I have that I am adding a negative 2 and 3 ninths to a positive 2 ninths. So remember that means you subtract and take the sign of the number with the larger absolute value. In order to subtract, I have to put the bigger number on top and then the smaller number. So that's how I subtract. 3 minus 2 is 1. Denominators stay the same. 2 minus 0 is 2. Stays at negative because the larger number is, the larger absolute value is the negative number. So k equals negative 2 and 1/9. Okay? So you put the bigger number, when you are adding a, excuse me, when you're adding a negative and a positive, put the bigger number on top, subtract. Take the sign of the number with the larger absolute value. So 2 and 3 ninths is the bigger number, it goes on top. I subtracted, this has the larger absolute value, so it's negative. Okay, let me know if you need more practice with that. All right, we are rapidly running out of time, so let's keep it going. This is our answer, so we put it back in here. Negative 2 and 1/9 plus 2 and 1/3 equals 2 ninths. I know that this is negative 2 and 1/9 really plus 2 and 3 ninths equals 2 ninths. Okay? My negative 2 and my positive 2 cancel each other out. I have a negative 1/9 and a positive 3 ninths, so I subtract. 3 minus 1 is 2. Keep my denominators the same. This is the larger absolute value, so it's positive. 2 ninths equals 2 ninths. Okay. Pause now and do your practice. You should be back now from doing your practice, which was on page 98. Letter A, x equals 7/8. Letter B, k equals negative 11. Letter C, d equals negative 41 over 42. And letter D, p equals 12. Let me know if you have any questions about this concept. If you did not do your practice well, if you had trouble with that, please let me know. I would be happy to give you another video to help you on a little bit. Excuse me, a little more. Sorry. Didn't mean to sneeze, I promise. It's not COVID, it's just dust. Okay. All right, guys, have a great day. Love you so much, and I'll see you in the next lesson. Bye.